So let's look at Newton's second law. Newton's second law is the mathematical relationship between force exerted on an object and the motion. The acceleration of an object is going to depend on that object's mass and the force applied. So the net force acting on an object is going to cause that object to accelerate in the direction of the force. And we've already talked about this a little bit when we talked about Newton's law or first law. All right. We looked at net force and we looked at the movement of my pencil. So the larger the force acting on the object, the greater the acceleration is going to be. And this kind of makes sense, right? If you put a larger force on something, then it's going to accelerate greater or have a greater acceleration. The larger the object's mass, the greater the force is going to be needed in order to have the same acceleration. And that kind of makes sense as well. And if you think about it like a box, let's say you have an empty box and then you have a box, maybe you ordered something and it's come in on the porch and it's 50 pounds. So you've got an empty box and a 50-pound box. And if you push the empty box, you'll find that you don't really need to put a lot of force in to get that box to move across the floor. But if you try to push the 50-pound box from your porch inside, you're going to have to make a bigger force. You're going to have to push with more force to get that box to start moving. All right, so kind of think about it logically in terms of those boxes. That might help you out. So our mathematical formula for Newton's second law is force equals mass times acceleration, where F is force, M is mass, and A is acceleration. And just like in our other units, if you'll look at your reference table, force equals mass times acceleration. So this is the third formula that we have encountered. All right. And again, it is going to be over here labeled for you where F is the force, M is the mass, and A is acceleration. So we've already learned what A is in our previous unit. Okay, we can also look at force in terms of mass times G, where G is gravity, but gravity is the acceleration, all right, due to gravity. So these formulas are really the same thing, all right? If we just use this formula right here, acceleration due to gravity is 9.8 meters per second. So you can plug that in. So really, this is the only formula you need because acceleration can be whatever the acceleration is. So let's do a practice example. Force equals mass times acceleration. So let's set up our triangle. All right, mass is being multiplied by acceleration. So here is our multiplication within our triangle. Yes, because this line right here means multiply. So two things being multiplied. What two things? Mass and acceleration. So the remaining portion of my triangle has to be force. It takes a force of 3,000 newtons to accelerate an empty 1,000 kilogram car at 3 meters per second squared. If a 160 kilogram wrestler is inside of the car, how much force will be needed to produce the same acceleration? Okay, so we are looking for force. So when we cover up our triangle, we see to solve this problem, we are going to take mass and multiply it by acceleration. Now, here's where it gets a little bit tricky. All right, what is the mass? I have a car that is 1,000 kilograms, and inside of the car is a wrestler with a mass of 160 kilograms. So I have to add those together to get my total mass. Now, my acceleration is 3 meters per second squared. So here is my total mass times my acceleration, which is 3 meters per second squared. And remember, meters slash second is the same as meters per second squared. So when I plug this into my calculator, I get 3,480. So my units are kilograms times meters divided by seconds squared. And force, if you'll remember, we said from our previous unit, force is measured in newtons. So N is the symbol for kilogram times meter times second squared. So we're just going to write a N.